different color up here for you. That velocity axis that we had, still going to need that. 0, whoops, 0, half, 3 halves, okay, so we're going to need, if we want to know the displacement, the distance from where we ended, from where we started, we need to know, where did we start? So we need to know the position at time 0. Well, we have the position equation. It's right here. I'm going to just go ahead and plug into it. 5 sine 0 plus 5. So this will be 0 plus 5, or 5. Okay, so far? And we need to know where we ended. So at 3 halves, 5 sine 3 pi over 2 plus 5. 3 pi over 2 is negative 1 plus 5. So we ended at 0. Good so far? So now we have to do end minus start. There's no calculus here, by the way. 0 minus negative 5. Oh, positive 5. Sorry, my bad. I'll erase. I think I just wanted to use the eraser. Okay, 0 minus 5. And hopefully you notice this is exactly the same number as we got the other way. Okay, started at 5, ended up at 0. Okay, moved right and then left. Now let's go to total distance traveled. We've actually already done, I've already done part of that. I'll call it TDT for short, total distance traveled. Looking at that velocity axis again, for total distance traveled, you're not only going to need the beginning and the end, you're also going to need any other place where the particle stops. So we're going to need the half as well. I'm not going to do the other two again because we have them, but we do need to do position at a half because it did stop at a half. So 5 sine pi over 2 plus 5. At pi over 2 we've got a 1. So this one is 10. Okay, so here's what we do. We do end minus start, but we do them for each little section. And you're going to need absolute value signs here for total distance traveled, just like you do in the other method, because you don't care the direction that things going in. You want everything to be positive. You want all the distance just added up. So we're going to do the position at a half minus the position at the start. Okay, so position at a half, that's 10. Whoops. Minus position at the start, which is 5. Absolute value sign's not doing a thing. So what this is telling you is that was forward motion. We knew that velocity was positive, or to the right if you want, depending on your problem. Could have been right. So the particle moves right. Now we're going to do the second half of this, or second piece of this. We're going to start at the end, position at the end, and we're going to go to the position at a half. Need absolute value signs though, because we want the total distance. We know the end is 0, and the half is 10. Okay, absolute value signs do matter here. So this is backward, or left. Okay, and it makes sense if you think about the displacement. If you go 5 steps forward and 10 steps back, right, you'll still be right here, 5 steps behind where you began. That makes sense? Okay, but if I add these all up because I really want total distance traveled, I get 15 total meters, exactly like I did with the other method. Okay? So, I'll put your homework right on here too. The homework is actually really short. It is page 309. Before we do this, though, we are going to go over that AP, but we'll do page 309, 2, 5, and 15. I have to explain a tiny bit, though. You might want to actually look at 309, which is the very next page on this. It says sketch the velocity graph. You don't have to do that. So I'm going to say for these two, no sketch. You don't need one. Okay? And you can only do method 1 for those because you don't have any position equation for that. But for 15, I'd basically like you to do 15 twice. I'd like you to do 15 by both methods. Not by both. By both. That means you're going to have 2 ways to do displacement and 2 ways, bless you, to do total distance traveled. Okay? I didn't make you an answer sheet, so I'll give you the answers right now. It's very short. 2. Displacement is -3/2. TDT is 31/6. Yep, that's 5. And 15. Now remember, by both methods, obviously you should be getting the same answer depending, or that doesn't depend on the way you do it. Same answer either way you do it, I should say. There. Okay. Anybody confused about what you have to do homework-wise? Okay. There are a couple of trig ones, but there's also one that's not a trig one.